In this lesson, we're going to go over locus. Locus is a point or a set of points. So for example, we may look for the locus of points that are a certain distance from a point. So for example, we have this point A here. We want to find all the points that are 3 inches from it. So if we measure 3 inches, we may come to right here. So that satisfies it. Also 3 inches may be over here as well. In fact, we'll find that there's a lot of points that are 3 inches from point A. In actuality, our solution, or our locus of points, would be a circle. So the locus of points that are a given distance from a point is a circle. This would satisfy, any point on this circle would satisfy the condition of being 3 inches from point A. Okay, another example would be a locus of points a certain distance from a line. So we may have a line, and we want to find the locus of points that are a certain distance from this line. So if it has to be d units from this line, we say that this distance here, so like we have this point as being d units from it. Also this point may be d units from the line, and this point here is also d units from the line. So what we find is that, again, there are many points that are going to be d units from this line. So our locus would be anything on this dashed line. And as long as this line continues, our solution, our locus, will continue as well. So we have to put arrows on there. But this isn't the only solution. Could also be d units below the line. So we have a dashed line below as well. So the locus of points that are a certain distance from a line is 2 parallel lines. So locus of points that are a certain distance from a point is a circle with a radius of that distance. And the locus of points that are a certain distance from a line would be 2 parallel lines, one above and one below the line. Now let's look at the locus of points that are equidistant from 2 parallel lines. So let's say we have 2 parallel lines, and we want to find the points that are equidistant from these 2 parallel lines. So in order to be the same distance from both of them, we should find a point that's in the middle. Like right here, this distance and this distance would be the same. That's not the only spot, it's also equidistant here. What we'll find is that the locus of points that are equidistant from these 2 parallel lines is actually a parallel line directly in between the two. So any point on this dashed line would be equidistant from these 2 parallel lines. Now let's look at the locus of points that are equidistant from 2 intersecting lines. So we have 2 lines that intersect. We want to find the points that are equidistant from these 2. Well, the locus of points will be a line that bisects them. So for example, something like this would be equidistant from the two lines. So any point on here would be the same distance from this line as from that line. So this distance would be the same as that distance. But this isn't the only one. That's just a vertical line. In this case, a horizontal line would also be the solution. Because again, this distance would be the same as this distance. So the locus of points that are equidistant from two parallel lines would be a parallel line directly in between the two lines. And the locus of points that are equidistant from two intersecting lines would be two lines that bisect the angles formed by the intersecting lines. So when this line is drawn, not only is it the same distance from both sides, but it makes two congruent angles. These two angles have the same measure, and then these two angles would also have the same measure. Now let's look at the locus of points that are equidistant from 2 points. So the points that are equidistant from points A and points B. Well, you probably figure that the point right in the middle of these two would be equidistant, and that would be correct. But you can actually go up a little bit, and then this point will have the same distance. This point here will be the same distance from A as it is from B, and also this point. In fact, it will be a vertical line going right through the center. This would be the locus of points equidistant from these 2 points. An interesting fact would be if we had a line segment AB drawn, well, this locus would actually bisect it. So if we gave this a letter and called it C, AC would be congruent to CB. So this length, call it length L, would be the same as this length, also length L. Another thing to know is that when this line comes down through line segment AB, not only does it bisect it, it's perpendicular to it as well. This is a 90-degree angle. So the line that is the locus of points equidistant from points A and points B is a line that would be the perpendicular bisector of line segment AB if it were to exist.